Dear colleagues, we would like to present our topic Intelligent Method of Secure Routing in Software-Defined Networks. An intelligent system is one of the type of automated information system that are based on knowledge. The essay of researching intelligent software system and organized knowledge base become relevant. A special decision support system in various fields, including network security. This work is dedicated to a relevant scientific applied problem related to analysis of threats, attack target, and improvement of potential solution for enhancing level of network security in the data plane of SDN network through the use to intelligent routing method. The purpose of work is to research and improvement of exciting method of security routing in software-defined network using intelligent support tools. A number of secure routing models have been developed and investigated taking into account base vulnerability critical metrics. An exciting model has been refined, leading to formulation of an optimization-based flow model for security QoS routing that you see on this figure. Numerical analysis has demonstrated the efficiency and adequacy of proposed refinement. Therefore, network function visualization consists of three main components: VNF, virtualized network function, or network function implement in software that can be deployed within a NVVI, network function virtual infrastructure. NVVI, common hardware and software component where they are deployed, virtualized network function. And the last one is management and orchestration environment. So, security threats related to SDN infrastructure are classified based on affected level as follow: application management, data lies, application management interface, and management interface. From respective of intelligence, third and fourth levels draw maximum attention, as knowledge base can be created by shaping this knowledge from system text message. Widen the scope of this work, typical security problems that attacked object within the data plane network device controlled by SDN control are analyzed. The result of analysis are present in table that you see on this slide. Clearly, device at various network level can be object of attack, and according to well-defined multi-level architecture of SDN, security threats can be classified and differ in different levels. The basic group of metric represent interval vulnerability characteristic that remain constant over time and across user. It consists of three sets of indicators. Exploitability. This indicator reflects easy and technical means by which a vulnerability is exploited. This type of indicator includes attack vector, attack complexity, required privilege, and user interaction. The second set is impact. This indicator indicates degree of impact on core security goal, confidentiality, integrity, and availability. And the third one, scope. This indicator is part of the base metric group, although it's somewhat independent of the rest of group. Despite the numerous security challenges in cloud computing, Cloud Security Alliance has identified 12 critical security threats related to nature of shared on-demand cloud computing that have the greatest impact on corporate business. You could see all of these 12 elements on slide. With the growing interest in software-defined networking and widespread development of SDN, their vulnerability is combating cybersecurity threats are gradually becoming apparent. Security questions are closely related to characteristic of SDN. According to research, the following aspects make software-defined network vulnerable to attack. Within the SDN architecture, separate levels are implemented to control plane and data plane, unlike traditional network where these planes operated in a single device. The control plane formulates flow rules, while the data plane is responsible only for forwarding data packets according to flow rules. For example, the lexicon used in such system, which is fundamental for creating knowledge base in intelligent system, is provided in table that you see on this slide. This stage is necessary for forming a system of features to create logical equation. The specification identifier, a base metric, characterizes the overall complexity of implementing an attack using a particular vulnerability on the node of network. We propose an approach based on finite predical algebra and method of comparison. The general form of such problem is built on base of predicate equation. Let the feature variable denote certain property of object, for example, the metric value of calculating base vulnerability metric of network element. Each variable takes values from its domain. Unlike Boolean, variable can take value from different domains. Let's describe variable features by a set of which we can determine possible values of property variable. Properties and features can be related to each other in the form of complex logical dependence, which can be represented as predicate equation, where P is a finite predicate. Classifying the considered object means determine based on this predicate equation and experiment data about the features, which property this object has and which property it doesn't to correspond it to. Then based on the priority dependency and experimental data on the features, it's possible to determine to which class the given object belongs. As evident from the above consideration, the values of feature are grouped into a matrix. Suppose this is a result of the experiment. We obtain some data related to values of features, describe the classifier object, and complete the following predicate equation. Describe the relationship between them. The task of object classification can be formalized in solving the following predicate equation by finding the unknown predicate f. In research related to logical interface in knowledge-based, question areas about the tiniest of relationship between the features of this object as well as question about their signification or insignification. It has been provided that the formal relationship between features is stronger the fewer sets of values of the variable satisfy the equation. A comparative analysis is exciting model of secure routing, a QoS routing model with a metric analog of the OSPF protocol, and improved model of security QoS routing taking into account base vulnerability critical metric has been conducted. The study provides the equality and effectiveness of the proposed model, the flexibility of using intelligent method for security routing. To achieve this goal, standards for building software-defined network were analyzed. It's noted that SDN is a modern approach to design, building, and operating information and communication network by separating management and data forwarding plans. This distribution provides network with direct programmability and dynamic as well as abstraction of functional capability from infrastructure layer. Network function virtualization has become a standardized view of development, implementing, and managed network service. However, growing interest in SDN and their deployment has revealed the shortcoming in combating cybersecurity threats. Based on research of typical security problem, it becomes apparent that centralized control and SDN programmability features provide powerful and convenient chance of attackers. The analysis of vulnerability in SDN data plan and functionality capability of routing means to counter possible attacks showed that prospect of using security routing tools based on basic vulnerability critical metric to enhance the network security level of SDN data plane. In turn, the analysis of CVS standard for quantitative vulnerability assignment of network equipment provides feasibility of its use in development and research of promising approaches to security routing in field of intelligent data processing and in software configured network. Thank you for your attention.